Okay, section 3.2, part B. Again, talking about the remainder theorem. All right, yesterday we learned how to divide polynomials using long division. Today we're going to use actually a quicker method called synthetic division. So what we want to do is, again, we want to divide x plus 1 into this polynomial. But rather than using this entire polynomial, I'm just going to use the coefficients of them. And we're going to draw our division line a little bit different. I'm going to leave enough space to write two lines here, and I'm going to write the coefficients of the polynomial on the top line. So this would be 1, a positive 2, a positive 3, and a positive 1. And then on the outside of here, we are going to take the 0 of this binomial. So as if we were to solve for this binomial, this x value would be a negative 1. So we're going to take this negative 1 and put it outside of the bracket. All right, so just divide using synthetic division. Very simple. We always take this first coefficient and just drop it down. And then we multiply these coefficients. Negative 1 times 1 would be a negative 1. And then I'm going to write it in my next place value. And then I'm going to add these coefficients. So 2 plus a negative 1 gives me 1. I am then going to multiply again. Negative 1 times 1 would be a negative 1. Place it underneath the 3. Add these coefficients, which is a 2. Multiply again. I get negative 2, and then I add. And then when I go to write my quotient of this last value that I got is always going to be your remainder. This value is called the constant. This is going to be your x term. And this last value is going to be your x squared term. All right, so when I divide x plus 1 into this polynomial, my quotient ends up to be x squared plus x plus 2 with a remainder of 0. Done. So a lot quicker method. All right, what happens if I were to divide a polynomial that works out to be a fraction? Same sort of thing. I'm going to solve this for x, which would be 3 over 2. I am then going to place the coefficients of this polynomial: 2, 1, negative 4, and a positive 3. I'm going to put this 3 halves on the outside of my polynomial. I'm going to first drop my coefficient down, which is a 2. I'm going to multiply, so 3 halves times 2 ends up to be 3. I'm going to add these coefficients, which is 4. 4 times 3 halves ends up to be a 6. I'm going to add negative 2 times 3 halves would be a negative 3. Oh, sorry, this should be a positive 2 and a positive 3. And I get a remainder of 6. All right, so I'm done. So my quotient would be, remember, this is my remainder, this is my constant, this is my coefficient on the x term, and this is my coefficient on the x squared term. So my quotient would be 2x squared plus 4x plus 2, remainder 6. Done. And that is synthetic division. Okay, this we're going to take into what we call, we're going to actually talk about the remainder theorem today. So what we should notice is if I ask you to find p at negative 1, then what I'm asking you to do is substitute negative 1 into my x value. So for this first polynomial, if I substitute a negative 1 into my polynomial, what you should notice is that I get the remainder value. So when I substitute a negative 1 into this polynomial, I end up with the same remainder as if I was dividing it by x plus 1. All right, so let's see what happens here. So I divided this by 3 halves, which is essentially the same as 1.5. I am now going to find the value at 1.5, or 3 over 2, whichever you want to use. And when I evaluate this, I get a value of 6. So by substituting in the value that we're actually dividing by, the 0 that we're dividing by into the polynomial, we end up with the remainder. So here is the remainder theorem. It states when a polynomial in x, p of x, is divided by a binomial of the form x minus a, the remainder is going to be p at whatever that a value is. Okay? So example 2, using the remainder theorem, determine the remainder when 2x cubed minus 4x squared plus 3x minus 6 is divided by x plus 2. Well, I could actually divide this using synthetic or long division to figure out my remainder at the end, but I don't need to do that. To find the remainder, I simply substitute in, if I'm dividing this by an x plus 2, I'm going to substitute in a negative 2 into my polynomial, evaluate this, and that will give us our remainder. So it ends up to be 44. So when the polynomial is divided by an x plus 2, the remainder is going to be 44. Okay, what about this polynomial? 11x minus 4x to the 4th minus 7 is divided by x minus 3. So same thing, if I divide this, or if I substitute in a 3 into my polynomial, I get a remainder of negative 298. All right, so how is this useful? Well, working through some examples now, right? It says, given the following dividend, find the value of k if the remainder is 3. So what is this telling me? It's telling me that if this is my polynomial, x cubed plus kx squared plus x plus 2 is divided by this binomial, then the remainder is going to be 3. So if I substitute a negative 1 into my polynomial, this should equate to 3, because that is my remainder. So by substituting a negative 1 into my x values and making this polynomial equal to my remainder, which is 3, I should then be able to solve for k. So I'm going to substitute negative 1 in for my x value, make that equal to 3. Just simplify this on this side. So negative 1 cubed is negative 1. This just ends up to be a positive k. Minus 1 minus 2, or plus 2, equals 3. So on this side, everything actually cancels out. Negative 1, and a positive 2 is just 0. So I get a k value of 3. So technically this polynomial ends up to be an x cubed plus 3x squared plus x plus 2. Okay. When the polynomial p of x, which is 3x cubed plus mx squared plus nx minus 7 is divided by x minus 2, the remainder is negative 3. When the polynomial is divided by x plus 1, the remainder is negative 18. What are the values of m and n? So when you're asked to solve for two unknowns and you're given two pieces of information, this is my clue, or something's going off in my brain to say I need to set up a system of equations. So similar to what I did up here, I'm going to substitute in a 2 in for my x value and make this remainder equal to negative 3. And then I'm going to substitute in a negative 1 and make that remainder equal to negative 18. and that will set up our system of equations. So I'm going to substitute a negative 3. Nope, start that over again, sorry. The remainder is negative 3. We need to substitute in a positive 2 because this is what we're dividing by. We're dividing this binomial into this polynomial. So we're going to substitute in a positive 2. And we make that equal to our remainder. And then I'm going to substitute in a negative 1. This will just become minus 2n minus 7 and make that equal to negative 18. All right, so now I'm just going to kind of draw a line here to separate my work. I'm going to simplify all of this. So when we simplify all of this, we get a 4m plus 2n plus 17 equals negative 3. And below that, we get an m minus n minus 10 equals negative 18. Okay, separate that one more time. I get a 4m plus 2n. I'm going to move 17 to the other side, so it becomes a negative 20. And then we have an m minus n equals a negative 8. All right, so now I'm going to solve the system of equations. So I'm going to multiply this second equation by 2 so that my n's are going to cancel. So now coming up here, this becomes a 4m plus 2n equals negative 20. And then we have a 2m minus 2n equals a negative 16. I'm going to add these systems together so my n's cancel. So I get a 6m equals a negative 34, 36. Sorry. Divide by 6, and we get an m value of negative 6. Then we're going to take that, substitute back into one of these two equations. I'm going to pick this bottom one just because it's quicker. Negative m minus n should equal negative 8. Add 6 to both sides. I get a negative 2. And then n equals a positive 2. So here are my two values. All right, moving on to example 5. If x minus 1 is the divisor in the following synthetic division, calculate the values of m, n, and p. All right, well, if x minus 1 is my divisor, I am going to bring a positive 1 outside, and I'm just going to start to actually divide this and see where it takes me. So my first step, synthetic division, is always to bring down the 2. I am then going to multiply this, which gives me a 2. I'm going to add these values together, which gives me a negative 6. I'm going to multiply this, which gives me a negative 6. All right, so from here, what do I know? Well, if I add these two values together, this should equate to this value here. So I'm just going to set up my own algebraic expression over here to be able to solve for m. So m plus a negative 6 should equal a negative 2m. So technically m minus 6 equals negative 2m. Well, if I were to solve this, I'm going to bring the 2m to this side, which gives me 3m. And at the same time, I'm going to bring the negative 6 over here, which gives me a positive 6. Divide both sides by 3, m equals 2. So now that I know my m value, this is going to equate to 4, which I then need to multiply by 1 in my synthetic division. Or sorry, this should be negative 4, which I need to multiply by 1. So that tells me I need to now put that value here. So my n value is going to be negative 4. So m is 2, n is negative 4, and then to finally find my p value, well, 7 plus negative 4 is going to give me 3. So p would have to be 3. All right, and that is the second part of remainder theorem.